In this video, I'll be talking about advanced prompt engineering techniques. If you haven't watched the video on prompt engineering basics, then please go and watch the video that is linked here. So let's jump straight into the advanced prompt engineering techniques that you can use to get relevant, accurate answers from LLMs. So let's get started with the first one, which is the meta prompting. So meta prompting basically focuses on providing the structure to the LLMs that it should follow so as to solve a problem instead of giving it an actual example. So what I mean by that is, for example, if there's a mathematical problem and I want the LLM to solve it. So instead of actually giving it how to solve it, I'll just give the what of it. I'll just say what it needs to do in order to solve that problem. So I'll just give the high level structure to it that, okay, write the formula for the perimeter of the rectangle and then substitute those values into the formula and then solve the equation. Whereas in few short, I was actually giving it step by step how it needs to solve that, right? So instead of doing that, I'm just giving the high level here. So that is meta prompting. It is better than few shot in terms that there will be fewer tokens, and it minimizes the influence that the LLMs can get from certain examples, and it's zero shot. There's no example in it. And if you see, the LLM did a pretty good job and it actually came up with a correct answer for this. So next is the self-consistency prompting technique. What this is about is where model gets to evaluate different reasoning paths before coming up or choosing the best answer. So you can do this by giving few short chain of thought prompting to improve the model's reasoning ability for solving complex problems. So the example that I have taken here is when I was 3, my sister was double my age. Now I'm 34. How old is my sister? When I gave this to a model, it responded with a answer which was incorrect. So how we can improve on this is by providing it with a few examples, like a few short chain of thought prompting, and it will be able to reason through different paths and come up with the answers. So I tried the same prompt a couple of times and it went through different reasoning paths. And you can craft or write the prompt in a way so that LLM goes through all of these paths and chooses the answer which is best suitable. So that is self consistency. Okay. So now moving on to next one, which is generate knowledge prompting. Sometimes the models are not able to perform well when you're asking a question which requires some kind of knowledge in order to be able to answer that question. So, for example, here I have asked the LLM in cricket, a batter can be declared out on a no ball when caught by a fielder. Is this statement correct? The model says yes, which is not correct. And how can we improve that is providing the models with knowledge around that question. We can give a few short prompts here so that the model is able to come up with a knowledge of its own for this particular question and then use that knowledge as input to answer the actual question. So then your model will be able to perform much better. So here it says no, the statement is incorrect, which is correct. Next is prompt chaining. It is very similar to what we did above, but basically it's about breaking a big, large prompt into smaller subtasks or tasks which an LLM can execute on its own so that its performance increases, right? So instead of giving a very big prompt which has multiple actions to do, LLMs might get confused like we humans do. So it's better that you break that bigger prompt or bigger complex problem into smaller subtasks and give the LLM those subtasks to perform, and then use the response that the LLMs get from one particular subtask, feed that as an input to the next subtask, and keep on continuing. So that is prompt chaining. So here I have taken an example for creating a beginner friendly study guide on machine learning, and I'm asking the LLM to create a structured outline first, and then I'm using this structured outline as the input to next prompt where I'm saying that now that you have this structured outline, expand on the section called key concepts, and we can do it this multiple times. So now moving on to tree of thoughts prompting technique. It is a very interesting technique, and how it works is very similar to how we humans brainstorm certain options or evaluate certain options. Like, for example, I'll give an analogy in order to be able to understand this properly. So, for example, if I'm sitting in a system design interview and someone asks me, what database would you consider for designing a system which has like a lot of analytics data? So my first few thoughts will be, I'll either go with NoSQL databases or SQL databases. Okay. Then I will try to go deeper into, let's say, MySQL databases and evaluate all the features that it offers and see if it fits the solution that I'm trying to design. If not, then I'll discard it, I'll backtrack, come back to the NoSQL option, and then think about it if that is a better option or not, and finally choose it. This is exactly how tree of thought prompting works. LLMs form some basic thoughts, then goes and evaluates by approaches like DFS or BFS. And if that option is not the optimal solution for solving the problem that it has at a hand, it will backtrack, go and evaluate the rest of the options. And this way, it's finally able to come up with a single solution after evaluating multiple options. And I feel that this is a very powerful prompting technique that you can use when you are trying to solve some very complex problems. Here I have taken example of solving a Sudoku puzzle, and I've given a prompt. You can try this prompt. I tried this prompt on Claude, and it gave a really good answer. You can see it has like structured it into three different thoughts it had, and then here I'm not able to click it because this is just an image, but if you actually put it in Claude or any other model that you want to, you can actually see what all steps it did in order to evaluate or decide or solve this problem and come up with a solution. So this is that's all about the advanced prompting techniques. If you learned something from this video, don't forget to hit like and subscribe to my channel. Thank you.